So when you hear it's passing by Mars, it's passing by Mars at a great distance.
Something remarkable yet perplexing is unfolding in the vicinity of our solar system. The interstellar visitor, designated as 3I/ATLAS, exhibits unusual metallic signatures that challenge conventional astronomical models. Even more striking, these metallic elements appear to be increasing in detectable quantities at an astonishing pace. This isn't merely an intriguing astronomical find. It's an escalating situation prompting NASA to prepare for possible severe repercussions on Mars. In mere weeks, this distinctive interstellar comet, 3I/ATLAS, is projected to reach its perihelion, the nearest point to the Sun, positioned between the paths of Mars and Earth. The magnitude of these expanding metallic features is astounding, and their source continues to baffle experts. In essence, the ramifications of this astronomical spectacle are profound. NASA's apprehension regarding Mars. Initial sightings emerged through high-definition imagery from advanced observatories such as the Hubble Space Telescope and the James Webb Space Telescope. These revealed faint, ambiguous forms near the comet's core. Early on, researchers speculated these might be imaging errors, like dust particles or illusions from the comet's gas emissions. However, as more data accumulated and resolution improved, the anomalies' reality became clear. They were distinct, shiny formations, apparently dense and unlike typical comet debris. Most alarmingly, these features displayed structured geometries, sparking intense debate and conjecture in scientific circles. The scenario escalated from curious to critical upon discovering that these odd metallic elements weren't fixed. Instead, they were enlarging, and not simply expanding, but proliferating exponentially. Early data indicated a handful of modest metallic detections, each comparable to a compact vehicle, around 15 feet in diameter. In a short span, their count surged to dozens, with sizes growing to resemble a modest residence, about 40 feet. Recent months' observations show a quadrupling. Now, hundreds exist, some exceeding 200 feet, hovering near 3I/ATLAS. Often missed is the uniformity of this proliferation, hinting at a process more structured than haphazard space events. The consequences are immense. Primarily, the makeup of these anomalies confounds analysis. Standard comets consist of frozen volatiles, water ice, CO2, methane, mixed with particulates and stones. Yet these metallic features point to a divergent composition, rich in nickel, iron, and scarcer metals. This upends theories on comet origins and development, particularly for an extrasolar entity. Might this represent an undiscovered category of interstellar body? The foremost worry, keeping NASA teams vigilant nonstop, is the growing likelihood of a Martian collision. 3I/ATLAS follows a route skimming dangerously near the red planet. Though first assessments predicted a safe passage, the emergence and growth of these metallic anomalies alter the equation. These aren't insignificant flecks, they're substantial masses with considerable velocity. Should any dislodge or eject from the comet's pull via some enigmatic mechanism, they could turn into rogue projectiles. The risk isn't one colossal strike, but a hail of metallic impacts, pummeling Mars like a target range, a lesser-known detail. A solitary metallic body, even bus-sized, slamming into Mars could generate a dust plume vast enough to disrupt its thin atmosphere for years. The fallout might be catastrophic. This extends beyond Mars alone. It's about grasping cosmic fundamentals. Unraveling these anomalies' beginnings is crucial. Speculation about alien origins surges with space oddities, and while experts demand proof before entertaining it, the peculiar quadrupling of these metals complicates outright rejection. A lingering query: if growth persists, what evolves? How does this influence Mars missions ahead? We're poised for a groundbreaking cosmic revelation. The comet's traits indicate it's no ordinary frozen boulder. Hints of novel physics. The rapid escalation in metallic anomaly detection around 3I/ATLAS truly stumps investigators. It's not incremental, it's a quadrupling effect, where quantities and scales multiply by 4 in monitored intervals. This swift, uniform surge defies standard cosmic theories. Typical events like degassing or fragmentation wouldn't yield such consistent, quick buildup of heavy metallic forms. This prompts speculation on hidden dynamics, perhaps governed by unfamiliar laws. Simply put, this comet violates established norms. A prominent theory posits 3I/ATLAS as a novel celestial type. Not a classic comet, but a sophisticated entity with an exotic core or unknown internal drivers. The metallic signs could stem from a unified, expansive system. Envision an immense interstellar seed awakening under solar heat and rays, sprouting these metallic extensions. This demands rethinking interstellar object formation and capabilities. Shockingly, if the seed idea proves true, it suggests self-assembly or embedded logic in a space body, exceeding current knowledge. Another fascinating angle explores intense local electromagnetic fields. Suppose 3I/ATLAS functions as a space dynamo, generating strong magnetism that aggregates floating metallic particles and gases into bigger, organized shapes. Space teems with ions and tiny remnants. A comet-based system gathering these, especially dense elements, and accelerating their formation might account for the quadrupling. These fields could mimic a galactic smithy, pulling and molding materials. But what fuels such a massive electromagnetic setup in a seemingly dormant comet? This enigma fuels sleepless analysis sessions, evident in the urgent data crunching. Novel physics murmurs circulate discreetly among top scientists. When data eludes current frameworks, it signals incomplete theories. Could 3I/ATLAS's odd metals offer initial proof of a hypothetical force? Quantum theories hint that in extremes, matter forms unexpected stable complexes. Though speculative, the steady, fast growth strains natural limits. An underreported aspect, some experts revisit abandoned fringe ideas for fits to the odd incoming data from deep space arrays. The red planet lies squarely in this enigma's trajectory. With metallic anomalies quadrupling, what was a benign flyby for Mars now looms as a major risk. NASA is fortifying for impact contingencies, crafting responses to a possibly ruinous occurrence on the red planet. This transcends a mere asteroid encounter. It's assessing how metallic swarms might reshape Martian study and settlement prospects. The risks are enormous. Mars, half Earth's size at about 4,200 miles diameter, maintains a precarious atmospheric equilibrium. Its air is ultra-thin, under 1% Earth's density, mostly CO2. Though battered by impacts historically, a focused assault from numerous large metallic bodies could yield novel outcomes. Astonishingly, one high-speed metallic striker could excavate a multi-mile crater, hurling debris into the sparse air. Enthusiasm for Mars as humanity's next abode is widespread. Orbiters, landers, and rovers scrutinize it for ancient life traces and human prep. Perseverance, for instance, gathers samples for Earth return. Major impacts could impair or obliterate these tools. Dust veils might persist months or years, hampering solar ops and risking landings. Overlooked, atmospheric upheaval could hasten water vapor loss, aridifying Mars further. NASA's urgent focus, precise anomaly tracking. The task is daunting. These are small relative to the comet, numbering hundreds, and rising, complicating individual surveillance. Deep Space Network's vast 230-foot dishes labor ceaselessly, channeling info to supercomputers for path simulations. Yet predictions for these proliferating metals prove elusive, fueling extreme planning. Martian planetary defense concepts, typically Earth-centric, are debated. Intercepting the whole comet is infeasible due to timelines and range. Targeting big fragments with swift probes to deflect or shatter them is considered, though tech for quick multi-target ops against replicating forms remains conceptual. If anomalies self-repair or duplicate, intervention might worsen the swarm. It's a high-risk stellar wager. The puzzle intensifies, expanding known boundaries. Global space agencies' reaction highlights collaboration. The peril has unified worldwide telescopes and intellects in data sharing. This collective hurdle emphasizes unity as our prime asset against space mysteries. Advanced tracking algorithms and rushed mitigation research mark a planetary defense evolution. This showcases human adaptability amid duress. Overlooked. This groundwork bolsters Earth's safeguards against future interstellar surprises. The awe isn't solely the metals, but the cosmic vastness implied. 3I/ATLAS traversed potentially billions of miles from afar, bearing its enigmas. Alpha Centauri, nearest at 4 light-years or 23 trillion miles, underscores such journeys' scale. For 3I/ATLAS, to arrive with active multiplying features highlights cosmic durability and processes tenacity. Countless stars might dispatch analogs. Forward, the 3I/ATLAS episode will redefine missions and research foci. Emphasis on early interstellar detection will grow, affording study and prep time. Dedicated intercept probes could probe compositions definitively. This might spur exploration's next surge, fueled by stellar doorstep riddles. These anomalies could ignite deeper galactic insights. This narrative provokes reflection. With dramatic metallic quadrupling and NASA's Mars prep, is the full story visible? Or a vaster cosmic scheme emerging? It queries our universal knowledge and isolation. Regarding what's truly occurring, based on available data, 3I/ATLAS is a natural interstellar comet with an unusually high nickel-to-iron ratio in its coma, suggesting it's metal-rich or has enhanced metal outgassing processes. There's no evidence of solid, growing metallic structures or any impact threat to Mars. It's passing safely at about 30 million kilometers. NASA and others are observing it closely with probes, but not bracing for devastation. The quadrupling and geometric objects seem like dramatic embellishments, possibly inspired by spectroscopic anomalies, but not supported by reports. It's likely natural, though its composition is intriguing and warrants further study, perhaps hinting at diverse interstellar chemistry, not new physics or extraterrestrial tech, without more evidence. If anything more exists, it's the excitement of real science over hype.